Okay, so in the previous part, we have been discussing the LSTM as a neuron for you, right? We see the LSTM neuron can effectively address the gradient vanishing and exploding problem effectively. Also, it can handle both the long-term and short-term memory in this learning process. Also, according to the previous discussion, we also find that the LSTM with neuron is very complicated, right? It's very complicated. And this LSTM is too complicated and also inefficient to learn. If you play with this LSTM, you will find that this LSTM is much slower in learning than the conventional recurrent units. Then in this page, we try to introduce another variant of this neuron, of the LSTM neuron, which is called the GRU, or the full name is called gated recurrent units. So GRU is a variant of LSTM. It uses only one single variable ht for storing both long-term and short-term memory in state. Before we mentioned for LSTM, we have two parameters, the CT and the HT, right? For memorying the long-term memory and the short-term memory respectively. In the GRU, this neuron it uses one single variable ht for storing this true memory in one single variable in state. This GRU also adopts the neural gates for information selection as well. So we show you the GRU this neural architecture in this page. It receives two information, both the raw information xt as well as the previous neuron hidden state ht-1. Here we don't have the CT anymore, right? We only have one single ht-1 from the previous neuron. Inside we also have several gates. We define two gates, the ZT and RT. This ZT is very similar to the injection gate we defined before. And this RT is very similar to the forget gate we defined before, actually. Both of them they are defined based on the xt is the raw inputs as well as ht-1 is a hidden state of the previous neuron. By concatenating them together, we can define the ZT and RT as two gates, these two neural gates. And we also, of course, they are subject to different variables, WZ and WR as shown here, right? So we can define two neural gates, ZT and RT. Also, similar to the LSTM, we also define one pseudo hidden state in the calculation process, which is denoted by the HT tilde. We define this HT tilde as the updating version of the inputs, actually. Remember, we mentioned this RT is very similar to the forget gate. We decide which kind of information should be thrown away, which kinds can be preserved by the RT gate based on the HT-1. So by calculating the animal-wise product between this RT gate versus the HT-1, we can update its representation inside it. Also appended with these raw inputs, we can define the HT tilde as a pseudo hidden state by the current neuron. And this GRU combines both the previous hidden neuron state as well as the current one, this new one, by the ZT gate. This ZT is very similar to the injection gate. And here we just use one single injection gate to decide the weighted summation between the two inputs. The HT-1 as well as HT tilde as shown here. Remember that the HT-1 denoting the hidden neuron inputs from the previous neuron, and the HT tilde denoting the new pseudo hidden state for the current neuron. And by weighted summing them together, we can define the current neural state to be HT as shown here. This starts denoting the animal-wise product between two vectors. Okay, so this is another variant of the LSTM. We call it as GRU. This GRU works in a very similar way as the LSTM, however, it is much simpler. We simplify the LSTM into the new version. Inside, we have fewer parameters to be learned. Also, the architecture will be much easier, also simple. Similar to the LSTM, the GRU can also address the gradient vanishing and exploding problem in a similar way as like this one, right? And also, can improve the learning process, which will be much more faster than the LSTM. So based on both LSTM and GRU, we can build these recurrent neural nets and into a deep architecture by stacking them together. So we can use this LSTM and GRU in a very similar way as the conventional neurons, right? So by stacking them together, we can define a very deeper recurrent neural nets also over a very long chain. We can also learn them effectively without suffering from the gradient vanishing and exploding problem anymore. So for stage 4 of the project, you have to build two recurrent neural nets. You can decide either to use the conventional neurons or use this LSTM or GRU as a neuron for the model architecture. And you can also try to play with them to see their difference in the performance. Okay, here is a quick summary for this section. In this section, we discuss several topics about the sequence data and how to represent sequence data as well as how to handle them, right? We mentioned some examples of the sequence data and how to represent the text words as the sequence data by both the one-hot coding or the unique ID or by some embedding methods, right? Then we discuss the recurrent neural nets. It covers both conventional recurrent neural nets, the architecture, all the different RNN structures. Then we can discuss the gradient vanishing explain problems. What are the problems we are studying here, and also what is the main cause of this problem for the recurrent neural nets. At the end, we discuss this LSTM. We mentioned what is the LSTM, its internal structure, and why the LSTM can address this gradient vanishing explain problem effectively. And we also mentioned a new version, which is simplified version of LSTM. It's called GRU, right? And why the GRU is much more effective than the LSTM in the learning process. Okay, so we also have some after-class tasks for you to do. Please read the textbook on the recurrent neural nets, this section. Also some reading materials we provided with you. I think it's also the time for you to move to the step 4 for the project now, and you try to build these recurrent neural nets based on the knowledge we discussed in today's class. We'll also provide you with some source code for the LSTM with PyTorch, and you can also search for some other sources of the source code of PyTorch with the recurrent neural nets. Okay, so that's it for this section, and thank you a lot for your attention and the time on this section. And I hope you can learn something useful from this section for playing with the text data and also recurrent neural nets.